Good morning, class. Let me introduce myself first. I am Miss Clarice Calibo, or you can call me Ma'am Kali, and I will be your math teacher for this day. So, class, are you ready to listen and learn something about our topic today? That's good. So before we proceed to our lesson, kindly enroll to our Google Classroom with a class code of 4 with a small letter X, 5 with the small letters R, L, K, D. Or I will send the link to our group chat. In our Google Classroom, I will post there our lessons, assignment, activities, and even our quiz in this subject. Are we clear, class? Thank you. So, our topic for today is all about Fibonacci sequence and the golden ratio. So, some of people may think that mathematics are made just to torture our brains using a nonsense numbers and symbols. But what if mathematics is everywhere? Mathematics is present in nature, and our mathematicians are just translating to us the environment using numbers and symbols. Have you ever counted the petals in a flower? You might think that any numbers are possible, but you might surprise because nature it seems to favor to a particular set of numbers like 1, 2, 3, 5, 8, and 13. It may seem coincidence to you, but they some sort of numbers or a pattern. In the sequence, the next number is found by adding the two numbers before it. For example, 1 plus 1 is equals to 2. 1 plus 2 is equals to 3. And 2 plus 3 is equals to 5, and so on and so forth. This pattern is called the Fibonacci sequence. In early, this pattern was investigated by the Indian mathematicians like Pingala, Birahanka, and Hemachandra. But this pattern was popularized in Europe by Leonardo of Pisa, or also known as Leonardo Fibonacci. That's the name of the pattern. He is one of the most talented mathematicians in the Middle Ages because Hindu-Arabic system, which we use today, was popularized in the Western world primarily through his composition in the year 1202 of Liber Abaci, or also known as Book of Calculation.
In Liber Abaci, Fibonacci posed and solved a problem involving the growth of a population of rabbits based on idealized assumption. Well, the answer of this is the Fibonacci sequence.
And now, let's investigate the problem. Let's read. If two newborn rabbits are put in a pen, how many rabbits will be in the pen after 1 year? Assume that rabbits always produce one male and one female offspring and can reproduce once every month. Can reproduce once they are 1 month old and the rabbits never die. We start to the newborn pair of rabbit in the first month. Since they are too young to produce a offspring, when they get old in a second month, we still have one pair. This time, the rabbits are old enough to reproduce another. So, the start of third month, we have now a two pairs. So, on the fourth month, the old pair will produce another pair while the first set of offspring are will be old enough to reproduce. So on the fifth month, we have now a 5 pairs of rabbit. 1, 2, 3, 4, 5. So, by using the Fibonacci sequence, we will have now a 144 pairs in the beginning of a year. However, we need to find the number of rabbits after a year. So, we continue on the 13th term of the sequence. So, the answer of these problems is 233 pairs or 466 rabbits.
Fibonacci sequence is one of the wonderful series of numbers
which could start with 0 or 1. Let's visualize these numbers using square tiles. I will start in a 1 by 1 square and another one, then together they form a 1 by 2 rectangle. Above that, the 2 by 2 square. Next to that, the 3 by 3 square. Beneath that, a 5 by 5 square. Now, if we continue to do this and connect opposing diagonally continuously, it reveals the Fibonacci spiral. And this spiral to be seen in a lot of nature, architecture, artwork, human body, and beyond. Going back to the rectangle, what if we're going to divide the two dimensions numbers like 13 and 8? The result is 1.625. We notice that it's just like dividing the two consecutive Fibonacci numbers. Doing this to the highest possible pair of Fibonacci sequence, it will give us the golden ratio. Now, the golden ratio is approximately equal to 1.618, represented by the Greek letter P or pi. In math, golden ratio in term to use to describe the relationship of two figures, where the number it seems to be in a form of complementary ratio. Now, if you have a number A and a lower number B, and the two are in the golden ratio if the quotient of this is somehow near to 1.618. So basically, any ratio that close to this number is perfectly said to be proportion. Now, we have here a two formula of Fibonacci sequence. First is the recursive formula, where f sub n is equals to f sub n minus 1 plus f sub n minus 2. And now, let's try the examples. Given the recursive formula for the Fibonacci sequence, f sub n is equals to f sub n minus 1 plus f sub n minus 2. And now, let's try to find the f7. Fn is equals to f sub n minus 1 plus f sub n minus 2, and f7 is equals to f sub 7 minus 1 plus f sub 7 minus 2 is equals to f sub 6 plus f sub 5, which is the value of f6 is 8 and the value of f5 is 5. So 8 plus 5 is equals to 13, and that is the value of f7. And now, let's try to find the f8 with the same process. Since f8 is equals to f sub 7 plus f sub 6, and the value of f7 is 13, plus the value of f6 is equals to 8, and 13 plus 8 is equals to 21, and that is the value of f8 or f sub 8. And now, let's try to find the f9. Since f9 is equals to f sub 8 plus f sub 7, and the value of f sub 8 is equals to 21, and the value of f7 is 13, 21 plus 13 is equals to 34, and that is the value of f9. And the next formula is the exact formula of Fibonacci sequence, where we're going to use the golden ratio. To get the simplest form of this formula, we can simplify first the 1 plus square root of 5 over 2, and we can get the value of golden ratio that is equals to 1.618, as well as 1 minus square root of 5 over 2, we can get the 0.618. Now, we have the simplest form of this formula that equal to f sub n is equals to 1 square root of 5 times 1.618 to the n power minus 0.618 to the n power. Are we clear, class? Now, let's try to find the f sub 7 using this formula. And now, let's try to find the f sub 7 using this formula. So, f sub 7 is equals to 1 over square root of 5 times 1.618 to the 7th power minus 0.618 to the 7th power. Bring down this one. 1.618 to the 7th power is equals to 29.03 minus 7th power of 0.618 is equals to 0.03. 29.03 minus 0.03 is equals to 29. So, cancel out. So, 1 over square root of 5 times 29 is equals to 12.96. Round off is equals to 13. And that is the value of f sub 7. That is the end of our discussion. So kindly go to your Google Classroom. I already posted there our Kahoot quiz. Kindly click the link of that and answer that until 2 p.m. Thank you, class. Have a nice day.